In this video, you're going to learn a little bit about concentration and molarity, enough information so you can get going with what we need for equilibrium, although we will be spending more with this next semester when we spend more time with solutions in general. But you need to have at least a little bit of a foundation of how we figure out concentrations using molarity, and in addition to that, how we do dilutions, which will be another piece to this. So before we can kind of move too far, we have to first kind of review a little bit about what a solution is. And a solution, if you recall, is a homogeneous mixture of two substances, typically made out of two parts. You have your solute, which is the part that's going to be getting dissolved, and that's usually the one that has the smaller amount to it. And then you have the solvent, and this is the thing that's going to do the dissolving. In our class, the solute will almost always be a solid, although it could also be a liquid or a gas. And for our solvent, we will usually be using water because water is considered the universal solvent. You'll find out later that that's due mostly to its polarity and its ability to interact with ionic bonds. But for right now, just know that water is the one we're going to use. And you get what's known as an aqueous solution out of that. When you dissolve something in water, it becomes an aqueous solution. Easy example is good old-fashioned salt water. So if you remember from chemistry before, reactants in double displacement, or also known as double replacement reactions, are almost always going to be aqueous. The reason why they are is because they need to be dissociated so that the ions are free to interact with each other, therefore getting the reaction to take place. As a result, it makes more sense now to describe them in terms of concentrations rather than grams, since we're dealing with solutions, not solid products and reactants anymore. So to define this, a concentration is just the amount of solute dissolved in a given amount of solvent. The greater amount of solute that you dissolve in a certain amount of solvent, the greater the concentration is going to be, which is kind of like one of those well done moments. Yeah, if you have more stuff, it's going to be greater. Kind of a nice easy one there. The unit that we use for concentration is molarity, and it's a way to just quantify concentrations within chemistry. And it's symbolized with a capital M, which is convenient for its molarity. And molarity is basically in the moles of solute, so that's the thing being dissolved, calculated in moles, divided by the volume of the solution. Now, one thing that's very important for you guys to understand, this volume of solution is referring to both the volume of the solvent and the solute. So another way to look at it is it's the final volume. And even though when we talk about molarity, like this 15 molar NaCl, we say that it's also could be written as 15 moles of NaCl per 1 liter of solution. When you calculate molarity, you're not always going to have 1 liter. But if you're given a molarity, it's always per 1 liter. And that's kind of a big thing to remember. Now, another key thing to kind of get out of this is this thing right here, this 15 moles of NaCl per 1 liter of solution, is very similar, if you recall, to moles per gram, which is our molar mass, or if another way to look at it is grams per mole, which is our more usual way. And those are conversion factors. Well, you can use moles per liter also as a conversion factor, where you can flip it over into moles over liters, or liters over moles. This way, you're able to convert back and forth between the two, which is something that's going to become even more important next semester when we do solution stoichiometry. So, a couple quick examples. What would be the concentration of NaCl if 15.5 grams is dissolved in water to a final volume of 275 milliliters? So here we're going to solve for the concentration. And the first thing we have to do is get that grams of NaCl into moles, and then we can divide it by the volume, but in liters. So to do that, we're going to take our 15.5 grams of NaCl, and we're going to use its molar mass, which is 1 mole of NaCl, for every 58.44 grams of NaCl, and that comes out to 0.265 moles of NaCl. Now we have our moles, then we're going to divide that by the volume, but a key thing to remember here again is we don't want milliliters, it needs to be liters. So in case you forgot, 275 milliliters is equal to 0.275 liters. So now that we have it in liters, we can just simply take the two values, so 0.265 moles of NaCl, divide that by the 0.275 liters, which is the final volume of the whole solution. And when you equal that out, or punch in your little voodoo boxes, you get 0.964 molar NaCl. So that's its concentration. So I want you to try this real quick. what would be the concentration if the same amount of NaCl was dissolved in water to a final volume of 25 milliliters instead of 275 milliliters? So you're using the same 15.5 grams this time. So go ahead and pause the video for a second and try it out. Come back and you'll get your answer. Okay, so hopefully you figured out that you take the moles, 0.265 moles that we found in the previous problem, and just divide it by the new volume, 0.025 liters. And you see the concentration has jumped to 10.6 molar NaCl, which kind of leads us to the first thing. If you have less volume and the same amount dissolved, you're going to have a much greater concentration. There's one more example, and that's if you're given a concentration and a volume and we want to know how much mass did you need to get that to start with, how would you go about solving the problem? So for this one, you're going to want to start with the volume, because this 6.5 molar, which if you remember from previous examples, 6.5 molar can also be written as 6.5 moles per 1 liter, which means that's going to be our conversion factor between the volume that they gave us and the moles of the substance. And then it's just a matter of using molar mass to get from there. So when we start this, we start with 0.500 liters of magnesium hydroxide, and we're going to use our concentration of 6.5 molar to convert between volume and moles. Now, if you remember, the number of moles is always given by the actual concentration itself. So we're going to put volume on the bottom, and that's the 1 liter, and the 6.5 goes with our moles of MgOH2. And we could stop there, but we're not done yet because we don't want moles, we want the mass. So as a result, we're going to have to use the molar mass of magnesium hydroxide to convert between moles of MgOH2 and the mass of it. And if you look that up on the periodic table and you calculate out the mass, it comes out to be 58.33 grams per mole. Double check that everything cancels out. And the only thing that you're left with then is going to be our grams, which is what we're looking for, and that comes out to be 190 grams of magnesium hydroxide using correct significant figures. So hopefully molarity kind of makes a bit more sense, but that's not the only thing we have to discuss. We also have to kind of talk about this other thing called dilutions, because most of the time when we make solutions of things, we're going to make them from a larger concentration. We want to dilute them down to a safer one. This is typically done with acids and bases as we order them in stock solutions, but it could be in anything. And basically, we buy them in stock solutions because they're more concentrated, they're a little bit more uniform, and they're cheaper. Plus, they're more versatile. If we buy the concentrated type, I can dilute it down to what I need, as opposed to being stuck with a lower concentration. But you have to weaken it first by diluting it. And basically, dilution is just reducing the concentration of a chemical solution, typically by adding more solvent to it. So the main method for us is going to be add water. Now, when we do acids and bases, this is kind of like a save your life tip, or save your clothing tip if you would prefer to look at it that way. And that's you have to dilute acids and bases by adding them to water, not the other way around. Because if you have the acid and then you add the water to it, you can actually cause the heat to build up and cause it to boil over and splash. The question then is, how do you figure out how much you need to add? Do we just guess, or is there some way to figure it out? Luckily, there's a nice, easy little equation that we can use. So how do we go about calculating this? Well, we're going to use the equation MIVI equals MFVF, or sometimes it's written as M1V1 equals M2V2. It means the same thing. But in this particular equation, Mi is the initial molarity or concentration, Vi is the initial volume, Mf is the final concentration, and Vf is the final volume. Now, in most situations, you're going to know everything. Like if you're really working in the lab, you're going to know everything that you need for this except for that one, the initial volume. Because that's the one where you have to calculate how much do you need the stock solution to make a liter of something or 2 liters of something. But of course, we're going to give you some examples that aren't like that. So on your little note sheet, there should be several set of examples that you can work through. And this first one we're going to work through together. So the molarity of concentrated hydrochloric acid is 12.4 molar. What volume of the concentrated solution must be used to prepare 2 liters of a 0.250 molar solution of HCl? So as you can see, we're starting with the concentration of 12.4 molar. So that's going to be our M1. And we want to know what volume is created out of that. So that's going to be the V1, or I should say what volume of that do we need. And then we know our final volume right here. And we know our final concentration that we're looking for, which is not V, our final concentration we're looking for, which is right there. So it's just a matter of kind of plugging it in. So you're going to start with your equation, MIVI equals MFVF. Plug in the information that you do already know. In this case, we know we have 12 molar solution we're starting with. We don't know its volume. We have its ending concentration we're looking for and its ending volume. And then it's just a matter of doing general basic algebra to solve for it. In this case, distribute things around, and the volume comes out to be 0.0403 liters of HCl. On this example, I want you to try it on your own first, so pause the video here so you can kind of check to see if you understand how to do it, but figure out how much 3 molar sulfuric acid would be required to make 500 milliliters of 0.10 molar sulfuric acid. So you're diluting it down. So go ahead and pause it and see if you can come up with the answer. Okay, so hopefully when you work through, this is what you approached. It was the exact same type of problem as before, and hopefully found out it was 17 milliliters of sulfuric acid. Yay! Alright, let's do one more. This is a little bit different. We want to know what concentration of potassium chromate was used to make a 250 milliliter sample of 0.1 molar potassium chromate if you started with 5 milliliters. So in this situation, we're still solving for one variable, but instead of looking for the initial volume, we're looking for what was the initial concentration, what was the starting concentration. Not exactly something you're probably going to do in the real world, but it's a good exercise to make sure you're understanding how all the variables work. So go ahead and pause the video again, give it a try and see if you can figure it out on your own, and come back when you think you're done. Okay, so hopefully you were able to work through the problem. Your work looks like what it does up here on the screen. If you did it correctly, your answer should come out to be 5.0 molar potassium chromate. If you did so, give yourself a nice high five, a good little pat on the back, because you're well on your way to understanding how to use dilutions and calculate stuff. This is something we're going to be using in class as you make some of your own solutions. So it's important that you understand the concept and you can work through stuff. If you have any questions, of course, please bring them with you to class, but please try some of the practice problems that I also sent you. The answer key is posted up on Canvas already. Give them a whirl, check out your work, and see how you're doing. Bring those questions with you to class, and we'll keep working on it. Our next step is to apply this into equilibrium, so hopefully you're doing all right with this. All right, thanks for paying attention. Catch you guys in class.